Now let's look at solving absolute value inequalities. These problems are a little bit involved, so there's a follow-up video that you may want to watch as well. So first let's look at the steps, and let's look at an example. So here's an example that you might have. You might have 2 absolute value 3x plus 4 less than 12. The first step is going to be the same as you're going to isolate the absolute value term. And you're going to remember the sign flipping rule. That is, when you multiply or both sides of an inequality by a negative, the sign flips. The second thing is you're going to transform this into either an AND problem or an OR problem. And then the third step is you're simply going to solve. And we're going to talk about the rules about AND and OR problems in just a second. So let's look at this example. The very first thing you do is you're going to just isolate the absolute value term. So you're going to divide by 2 and divide by 2. You get absolute value of 3x plus 4 is less than 6. And at that point, we're going to stop and we're going to transform it. Because we're never going to solve this problem. We're either going to make it into an AND problem and an OR problem. And the question is how are you going to do that? And there's a real simple set of rules, and they're often called the GO-LA rules. They're called GO-LA because if it's greater than, it's an OR problem. Greater means it's OR. Less means it's AND. So as an example, if you have the absolute value of x is greater than or equal to 10, well, there's two ways that x can be greater than or equal, absolute value of x can be greater than or equal to 10. First is it can be 10 or something larger, obviously, right? For example, if it was 30, the absolute value of 30 is in fact 30, which is greater than 10. But can also be less than minus 10. And let's think about y, for example. If it was minus 40, the absolute value, let's just think about that for a second. If it's the absolute value of minus 40, the absolute value of minus 40 is 40. And 40, in fact, is greater than 10. So if you have absolute value of x is greater than or equal to 10, then you have it either greater than 10 or less than 10. We write x is less than or equal to minus 10, or x is greater than or equal to 10. The other example would be, let's say, absolute value of y less than or equal to 4. Well, if the absolute value of something is less than or equal to 4, then let's think on the positive side of it, it can be everything between 4 and 0, right? Absolute value of 4 is, absolute value of 3 is 3, and 3 is less than or equal to 4. But it can also be anything between 0 and minus 4. But it can't be anything that's not between those two numbers. So here we say that y has to be between minus 4 and 4. And those are the GO-LA rules. If you have a greater or greater than or equal to, it's an AND problem, where it's going to be bigger than the number or less than the negative of that number. If it's if it's a value, an absolute value of something is less than or equal to a number, it's going to be between those two numbers. So let's look at an example of each one of those. Let's go absolute value of 2x plus 4 plus 10 less than 18. First step is you're going to isolate the absolute value term, so that's just minus 10 and minus 10. 2x plus 4 less than 8. Now you have to think, is this and or? So this is less than. If it's less than, you know it's an or problem, right? Because we're going to use the memory tool here, go LA. If it's less than, it's no. Greater is or, less is and. So we made a mistake here, right? That's the reason we use go LA. So if it's greater, it's or. If it's less, it's and. This is less, so it's and. So 2x plus 4 has to be between 8 and a minus 8. So we changed the less than or equal problem into an and problem. Or I like to think of this as a between problem. This has to be between a negative 8 and a positive 8. And then you simply solve for x. So you subtract 4 and subtract 4 and subtract 4. Minus 12 less than 2x less than 4. Divide by 2 and divide by 2 and divide by 2. Minus 6 less than x less than 2. If you want to graph that, 6, 0, 2. It's everything between negative 6 and 2. It doesn't include minus 6 and 2 because it's less than, strictly less than, so you're going to have open dots. And that's going to be your graph if you're asked to graph it, just like that. Let's do another example. X plus 5. Let's do 3x plus 5 greater than or equal to 21. First step is you're going to isolate the absolute value term. There's nothing to add to both sides, but we can divide both sides by 3. We have absolute value of x plus 5 greater than or equal to 7. This is a greater than, so is it or and? Let's see, greater or less and, greater or less and. This is greater, so this is going to be an or problem. So that means x plus 5 is going to be less than or equal to minus 7, or x plus 5 is going to be greater than 7. So you isolate the absolute value term, you make it into an and or problem, and then you just solve the two separately. So you go minus 5 and minus 5, x is less than or equal to, that's a minus 12. Subtract 5 and subtract 5, and you get x is greater than 2. So it starts out greater than or equal to, so you always have the equal part of it, an or in between. There's your answer right there. X is less than minus 12, or x is greater than 2. If you want to graph it, you can just use a number line. Minus 12, 2. This is going to look like, it's going to be a solid dot at minus 12, and it's going to be more negative than minus 12. And then it's going to be a solid dot at 2 and more positive here. And that's how you do Go LA problems. So there's another video following this one, more absolute value inequalities, and you can watch that if you need further help.